All right, welcome everyone. Excuse me. So this particular video is entitled Graphing and Writing Equations of Lines, and you can see there is the standard that we're working on. So let's just go ahead and jump right in. There are 23 slides, so we have quite a bit to do. So the first example, and a lot of this is just a review from Algebra 1. So the first thing that I want you to pay attention to is they're asking you to write the equation of the line from basically given a graph. Now, the way this works, and again, you should probably remember some of this from Algebra 1. So what you need to do is, in order to write the equation, we're going to write our equation in slope-intercept form. And in order to do that, you are going to need a slope and y-intercept. Now, we can generally pick that out, but generally what you do is you need two ordered pairs. So let's jot down two ordered pairs. That one looks like it's slightly above, so I don't want to use that one. But I think I want to use this point right here. So that's going to be 2, 1. Okay, and then, oh, this one's a really good one. So this is 1, 2, 3, 4, 0. So I have x-intercept but not y. So first thing I'm going to do is I'm going to find my slope. So if you remember, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I always use the formula. If you use the triangle, that's fine. So you're going to have m equals 0 minus 1 over 4 minus 2. So negative 1/2. So m is 1/2. Now, take m and one of these two ordered pairs and write your equation. So what we're going to do here is we're going to, okay, so I'm going to take m equals negative 1/2, and then I'm going to use 4 0 because I always like when there's a 0 in the equation. I think it's easier. But you could just as easily use the other one and still get the same answer. So I'm going to put mine in the form y equals mx plus b. And so y is 0, m is negative 1/2, and x is 4, so plus b. Because like I said, it looked like it's slightly above, but I didn't want to make that call, so that's the reason I'm doing it this way. And so I'm going to have 0 equals half of 4 is 2, and it's negative, so negative 2 plus b. I'm going to add 2 to both sides so that b is 2. So then my equation is y equals negative 1/2 x plus 2. Okay, so again, when you take it from a graph, I took 2 points and I found m, and then I used m and one of the ordered pairs in order to write the equation. That's how that works if you're given a graph. So let's go to the next one. Please keep in mind, write this down, pause when you need to. Okay, so now here we're going to do the same type of thing, only this time I already know what m is, and I need to, and they're giving me the ordered pair. So I'm writing the information, giving you the information in a written form versus from a graph. Okay, so let's jump on that. And I think, oh, there we go. Okay. So I'm going to still use y equals mx plus b. Most people use slope-intercept form, you'll find. I don't know why, it's just what most people do. Okay, so then this is your x and this is your y, and then your slope, this is your m. So I'm going to have 3 equals negative 5/6 times negative 12 plus 3. And let me clean that up just a little bit because it's a little hard to read. Okay, so, and this is negative 12. Okay, so what you're going to do is you're going to have 3 times, see, 60 divided by 6, so this should be 10. Guys, just put this in the calculator if you don't know, it's fine. And use your fraction key, or if you're using a TI, use the math key if you need to come up, but you notice it just comes out to be an integer. And then this should be, oh, I'm sorry, that should be b. I'm not sure why I wrote 3, but let's put a b here. Okay, so then plus b. Now I'm going to subtract 10 from both sides, and so that b is negative 7. So then y equals negative 5/6 x minus 7. Okay, there's my m, there's my b that they gave me. Okay, so we're going to keep moving. Now, another example, okay, here, slope and then unordered pair. So again, this is x, this is y, and this is m. So I'm going to have negative 2 equals 1/4 times 3 plus b. So I'm going to have negative 2 equals 3/4 plus b. I'm going to subtract 3/4 from both sides. And when I do that, I'm going to move this just a little bit. I'm going to get b equals, and I'm actually just going to pull my calculator out and do that. So negative 2 minus, and then a TI, which is what I'm using. I'm going to do parentheses 3 divided by 4, close my parentheses, and then I'm going to hit math, and then I'm going to hit enter, enter again, and I get negative 11/4. If you're on a Casio, just hit negative 2 minus, and then 3 fraction key 4 equal. Should give you an improper fraction, but if it doesn't, you can change it to a mixed number. The button you're using for is F to D. And if you don't know where that is, please just ask me in class and I'll let you know. So now we have our equation. So y equals 1/4 x minus 11/4. Okay, so notice the same thing we did in the last one, because the slope was a fraction, so I had the slope and I had an ordered pair. Okay, moving right along. Okay, now this one's a little bit different in that I have to find the slope first. This was like the one we did in example 1 where we took it from a graph, only I don't have to identify the ordered pairs. They did them for me. So I'm going to use m equals 1 minus a negative 9. Again, I'm using my formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, that's your slope formula. You guys should remember that from Algebra 1. And then 3 minus 7. So that's going to be 10 over negative 4. I'm going to simplify it down because anytime you can simplify a fraction down, it makes your life much easier. Okay, so it reduces down to negative 5/2. Okay. Now I'm going to take this and one of the two ordered pairs and write my equation. I'm going to use the smaller one because the smaller the numbers, the better. Why work harder than you need to? And again, if you remember, this is x and this is y. I don't like that color. I'm going to change. I'm tired of the blue. Let's go down a little bit. And so we have 1 equals negative 5/2 times 3 plus b. So 1 equals negative 15/2 plus b. I'm going to take 1, whoops, let me erase that. All right. I'm going to move it down just a little bit. I'm going to add 15/2 to both sides. Okay, so that b equals, and then I want to do, which is basically 2, so 17/2, because 1 is 2 over 2. So 17/2. So y equals negative 5/2 x plus 17/2. Okay, and there you go. Okay, now again, same type of thing. Now, one of the first things though I notice when I look at these two equations is notice that your y values are exactly the same. Okay, that means that this is going to be a, let's see, y equals, so it's going to be a horizontal line through y equals 3. Now you can do all of the stuff you normally do, but why bother? That's just a lot of work. Oh, and that should be negative 3. Okay. When the x's are the same, then it's an x equal equation through that number. If the y's are the same, it's a y equal equation through that number. Okay. Again, I wouldn't work that hard. And so here's where the example you're seeing that. See, notice your x's are the same, so it's x equals 5. Okay. Again, don't have to work harder than you need to. Just pay attention to whether one of them is the same or not. Okay. So now here we want to do a graph. Now you can do a couple of things here. You can either do x and y intercepts or you can do slope intercept form. This one actually lends itself very well to x and y intercepts. Let me see if I can show you what I mean with my tool. Let's see. Oh no, I don't want anything that big. That's huge. Okay, that actually will work. So here's what I do. Cover that up, okay? If you cover that up, then what you have is 2y equals 6. Divide both sides by 2, so y is 3. 1, 2, 3. This is if you're doing x and y intercepts. Now I'm going to take the same one. Now I'm going to cover up this one. What's left when you do that? You end up with x equals 6. 1, 2, 3, 4, 5, 6. I generally try to use x and y intercepts if the numbers look like they'll work real easy, and also if it's already in standard form. If it's not in standard form, I don't usually do that. So if you're going to do that method, x and y intercepts, which this is what I did, x and y intercepts, that's where you let x equal 0, find y equals 0, find x. Then here's your two ordered pairs and you're done. Okay. And let's see if I can draw a line through there. Hey, that wasn't too bad. Okay. So that's how you can do it. Now, if you're choosing, and I'm just going to move my little, whoops, that's not what I meant to do. Sorry. Alrighty, let's move that. Okay. Now, if I chose instead to do slope-intercept form, what you're going to do here then is, let's do this in a different color so you can see, because you'll see it's exactly the same line. Okay, so I'm going to subtract x from both sides, so I have 2y equals negative x plus 6. Okay, I'm going to divide all the way through by 2. So y is negative 1/2 x plus 3. So here I'm going to go up to 3. Notice it's the same one. And then I'm going to go down 1 and to the right 2. Now keep in mind, I drew mine by hand. Basically what you see, you're going to have the exact same line. It looks a lot better if they're straight. So just a heads up. Okay? They're basically the same line. Okay, it should go straighter, but again, you hopefully get the gist. And this is if you're using slope-intercept form. Okay, so just kind of a heads up on something you can do there. That'll help you out. Ooh, let's get rid of that. Let's undo that, because that just will get on the nerves. I've never done this before. I used this piece before. Let's edit, sorry, and undo. Sorry about that. There we go. Now, let's get rid of this then before, before we move on, because we know what a mess that looks like. Okay, so now you can do the same thing. Again, you can do slope-intercept form, but here I would honestly do x and y intercepts. Okay, let's see. Okay, so if this is 0, then this becomes negative 3y equals 12. Divide both sides by negative 3. Y equals negative 4. Okay, 1, 2, 3, 4. And then if you do the other one, so the 3y is gone, then it becomes 2x equals 12. Divide both sides by 2, so x equals 6. 1, 2, 3, 4, 5. Didn't we have 6 last time? And there you go. Okay? Again, x and y intercepts. I honestly think it's so much easier to do when it's already in standard form. Okay, now here they have us doing that, exactly that. So when you do x and y intercepts, again, let that be. So you're going to get y is negative 8 because you have negative y equals 8, so you change the sign. Then here it's going to be 4x equals 8. Divide both sides by 4, so x is 2. X is 2, y is negative 8. 1, 2, 3, 4, 5, 6, 7, and there's your 8. And then there you go. Okay. Now here, I don't know that you necessarily want to do that. Maybe we'll just solve this one for y. So we're going to have 1/2 y equals 3x plus 2. So what I did is I added 3x to both sides. So if you need to see that. Okay. You can't put those together because they're not like terms. Then you want to divide both sides by 1/2. But keep in mind, guys, that's the same thing as multiplying through the entire thing by 2. When you do that, you get y equals 6x plus 4. So then let's do slope-intercept form. So b is 4. 2, 3, 4. Go, it says up 6, but I don't have enough room. So what I'm going to do is go down 6 and to the left. That's the same thing as going up 6 and to the right, because negative over negative is positive. So I'm going to go down 6. 1, 2, 3, 4, 5, 6, and over 1. Same thing as if I had gone up 6 and then this way, because you'll see you'll get the exact same line. See, and I just think slope-intercept form for this one was so much easier. Please feel free to pause, stop, replay, ask questions when you see me in class. Either one's fine, okay? Now, here we have a word problem. Yay, because we know how much you guys love those, okay? So Dixie's house cleaning service offers a 3-hour job for $65 and a 6-hour job for $115. Write an equation. So basically what you need to do, you're going to use ordered pairs, and then you're going to do what we've been doing. So the ordered pair is going to be 3 and 65, and then 6 and 115. And the hint was find the slope and y-intercept. There are your two ordered pairs. So slope is going to be 115 minus 65 over 6 minus 3. And 115 minus 65. Whoops. You're going to have 50 over 3. Okay? Did I do that right? I think so. Okay. And then once you do that, take this and one of the ordered pairs and figure out what y is. So let's use the smaller one. So we're going to bring it down just a little bit. And so m is 50 over 3, and I'm going to use 3 and 65. Okay, keeping in mind that this is x and y, and I'm doing slope-intercept form. Y equals mx plus b. When you do that, you're going to get 65 equals 50 thirds times 3 plus b. The 3's are going to cancel, so I'm going to end up with 65. And if you're not sure, just put that in the calculator. Equals 50 plus b, so b is 15. Y equals 50 thirds x plus 15. Okay, hopefully I did that right. If I didn't, please let me know. In a nice way, of course. Okay? All right, here's another problem. Okay, here they suggest that you draw a picture first because it really does help sometimes. So he's jumping from an airplane flying at 6,400 feet. Okay, the wind carries him to a landing spot that's 580 feet away. Okay, this is the 6,400 feet. This spot is, and so keep in mind this is 0. This is the 580. Okay. Now, draw a picture. What you want to know is what is this? Now, keep it in mind, you guys had geometry. You could just as easily do Pythagorean theorem here because it's probably what I would have done. But if you didn't, you could just do ordered pairs. Okay? So if that's this point, that means that ordered pair is going to be 0, 6,400. And then this ordered pair is going to be 580, 0. And then find your slope and write your equation. Okay, that honestly is pretty easy. I think you can do that. So I'm going to let you finish that one. Okay, here's another word problem where we've given you the equation. They just want you to graph it. Okay, please keep in mind that T is here, and then A for altitude is here. And so you might make sure to change your scale. This might be a good one to plug in the calculator and kind of see what it looks like. It's the descent of an airplane. So keep in mind the slope. If you wrote this in slope-intercept form, it's A equals negative 2,000 T plus 26,000. So keep in mind that this is a negative slope, so it should be falling. It's a descent. That is your kicker right there. Okay. How long will it be before the airplane reaches the ground? Okay, here honestly is what I would do with this. I would plug this into my calculator. So I just got this new thing, so let me help you out with that. I'm going to pause it for a second and then. Okay, just wanted to show you what it looks like on both the calculators. So this first one, this is on the Casio. What I did is, let me exit this and I'll show you what I put in. I put in 26,000 equals minus 2x because I don't want to put in t. I wanted to put in x because I don't have an a. And then I told it, what I did is after that I changed the window just so I could see it. And I went from 0 to 20,000 scale of 500 and then 0 to 30,000 again scale of 500. And then I told it to, and then execute, sorry. And then I told it to draw because I wanted to be able to see the graph and I can see it. Now on the TI, I did exactly the same thing. Here you can see the equation. Here you can see what I did the window. This is actually really cool where you can see all that. And then here's the graph. Okay, so I wanted you to see how that goes in so that you can put all of that in. And then what you want to do, so that's what the graph looks like. You should be able to recreate that. And then what I want you to see is how long will it be before the airplane reaches the ground? Well, if you go back to both of your graphs, I need my x-intercept. So what I need here is I need shift and G-solve, and I think I want my roots. Yep. So here it's 13,000 is when it that's, is that 13,000? Is that right? Maybe I don't want my roots. Let's exit. Let's do G-solve again. Shift G-solve. I honestly never get to. I don't do this on a regular basis. Oh, let's execute and let's do shift and G-solve. Okay. Intercept. Nope, I definitely don't want that. I want to know what this point is. So I want to know what X is. Okay. And that's y-intercept, intersection, the roots. Okay. So I want to know what the time is. Let's go to the TI and let's look at it and see if it's an easier way to do it. On the TI, if you go to calculate, which is second and then calculate, what I'm looking for is my zeros. Okay. So let's see if we hit number 2, if that'll give us what we want. Say enter, and then enter, and then enter. Yep, I didn't think it would. Okay, so we're going to quit. Okay. Let's go to our graph again. And it didn't change, but that's okay. But what we're looking for is we're looking for what is this point. The other thing anybody can do is you guys can trace. So if I just, whoops, if I move down here, see how I'm moving down, you can see it bigger. I want y to be 0. Downfall of the TI, it's not going to go there exactly, but it's going to be pretty close. So the 13,000 that I got with the Casio, that was exactly right. Okay, so I just wanted you to see that. So when we did root, that's exactly what it was. So when X is 13,000. Okay. But now keep in mind, what does that mean? So let's go back. And let's go back. So I want you to see how you got it. So how long will it be? And so what's our time? I don't know, is that hours? The altitude's in feet. I'm not sure. You know what? Let me check on that one and I'll get back to you guys on that one. Okay, but that's what we're looking for. Here you're just graphing, and so what we want to do here is, let me turn this back on. Sorry, it went off. I will check on that word problem because I know I've done that one. I just got to make sure I'm giving you the right information. I don't want that to be wrong. So here's what we're going to do to graph when you're graphing is you start at a point. So we're going to go 1 and then down -4, 2, 3, 4. And then my slope is a -2. So I always do negative on top. So -2/1. I'm going to go down 2 and to the right 1. And bam. Connect it with a line. Okay, hopefully you remember that. Nothing different except we're not starting from y-intercept or the origin like we do in direct variation. Okay, now we want to know if this is linear, and if it is, write the equation. So you want to check, remember, and see what that's like. Okay, sorry about the phone. So this is 1, and then this is 2 and 2 and 2. So is that linear? Yes. Can you write the equation? Well, there's b, and then you just need to take any of these 2-ordered pairs and find the slope. So if I do 6 minus 4, that's 2, and 1 minus 0 is 1. If I do 10 minus 8, that's still what? 2, and then that's 1. So my slope is 2. So y equals 2x. And then here's, when x is 0, that's my y-intercept. So I'm going to use that right there. Sorry. And there's my equation. Yes, it was linear, and there's my equation. Okay. Do the same thing here. This is 5. Nope, this one's not linear. Not linear. Because of these, you can tell. Okay. Word problem. Oh, wow. Here, write the equation. Okay, pay attention. Number of players, but right now we don't need that information. There's a one-time setup charge. That's our B. So plus 25, and then it's $32 per hoodie. So 32H is going to be the cost of the hoodies. Okay, so I'm going to put C for cost, H for hours. Okay. And then when you graph that, what does the slope represent in this particular problem? Well, if you go back, the slope represents what? The cost of each hoodie. What does y-intercept represent? I mean, what is, yeah, y, oh my gosh, I got so mixed up, sorry. Slope is the cost of the hoodie, that's true. And then y-intercept, what is that? That's the startup cost. That's the money you have to pay before you even have any shirts or hoodies done. Okay, and then they ask you to graph it. Okay, so you can do that. Sorry, I got a little confused there. Bigger picture so you can do the graph, make your scale. I think you can do that. Okay, is it continuous or discrete? You got to think about it now. The kind of money. This actually is going to be a discrete function because it's $32, and so there's not going to be any in between. What's the end behavior? The more hoodies you order, the more the price goes up. Practical domain and practical range. Okay, what kind of numbers are you using? So think about that a little bit, and we can talk about that a little more. All right, and then total cost of the hoodies. What happens if you change that? What does it do to the equation? What does it do to the graph? So I actually would like you to try all of that. But guys, that'll be the end of this video. So thank you very much.